Good afternoon, everybody. So I want to thank you all for coming and to our DAS Design and Deployment from Start to Finish panel. We have a great group of panelists today. They have a combined 100 years of experience servicing the wireless industry. Starting us off will be Jeff Reale of Antenna Systems. Jeff's going to be discussing the DAS design phase. He'll be discussing determining venue needs and specific requirements. This will include determining existing macro service at venues, as well as designing a system to meet the venue's needs. Following Jeff will be Fred Bancroft of Corning. Fred will discuss the DAS architecture. His presentation will include topics such as equipment selection and the convergence of multiple technologies over one single platform. Next will be Ray Kramarcy of Alpha Technology, and Ray will discuss powering up the system within the venue. He will focus on two segments, the head-end area as well as the remote access units. He will also discuss backup power considerations as well as space issues within the venues. Next, Carla Shaffer of Anixter will discuss project management and system implementation. Her presentation will highlight the importance of coordinating material, construction planning, installation management, and validation of the systems. She will also discuss just working together with the contractors, the integrators, making everything work together. Finally, Art Meierdirk of INOC will discuss operations and maintenance of the system. He will highlight key operations and maintenance and support issues that need to be considered actually at the start of the design phase. He will also hit topics which he will discuss following construction. Now we have five presenters today, so we do have a limited amount of time, but following our presentation, we will open up the panel for a Q&A. But to the extent that we can't get to everyone's questions, please feel free to approach us after the presentation. So without further ado, Jeff, please start us off.
Thanks, Jordan. Appreciate it. First name is Jeff, last name is Reale. I've been in the DAS industry now for about 13 years, wireless in general for about 17 or 18. When I started out, I spent the first 9 years of my career working for a wireless service provider. 5 years as a macro cellular RF engineer and 4 years as a project manager deploying DAS solutions. Then I made the jump to a DAS product manufacturer, and for the last 4 to 5 years, I've been working on the integration side. So I've seen this industry from a lot of different angles, and I've seen it evolve in tremendous ways over the last probably 5, 6, 7, 8, 9 years. So we're going to try and lay out a blueprint for you today that it was hopefully smooth out some of the bumps. The DAS industry can be very complex. There's a lot of moving parts, and it's only become bigger and more complex over the last handful of years. But Antenna Systems, having been in the business since 1998, we put together a fairly methodical process that kind of walks you through each and every one of the steps needed. All the bases are going to be covered, and hopefully you can have a much smoother implementation where you don't run into some of the commonly held snags that kind of hold us back every now and again. So this is a really obvious slide. I realize that I'm pointing out the obvious, but the keys to success on a project, you got to have really good planning, good execution, good leadership, and good communication. It can't be overstated. There's an awful lot of areas and situations where one of these things kind of falls out of the mix on a 3 to 6 to 9 month process, and it becomes a lot more difficult than it really needs to be. So the rest of the presentation is really built on a process that provides a blueprint for handling all the various tasks that come into play. Now, a company like Antenna Systems as a legacy DAS integrator that's been around for a long time, we can do all of these things, or we can do individual tasks to fill in the gaps. So the ecosystem within the DAS space has become a lot larger over the last handful of years. So there's many more players, from consultants and low voltage installers, and just an awful lot of players that we're working with these days. So we've kind of migrated our business model a little bit away from the turnkey aspect of things and more into the smarts and parts, where we dive into the design process, we help out with the requirements definition, we pull off the system acceptance testing, the commissioning and optimization, but a lot of times other parties and other organizations fill in other gaps on implementation, on material procurement, on some of the design work. We've been working with Ray's team to upgrade our power plant capability for a lot of our DAS solutions. We work with Fred's team on a lot of the next generation product designs. So those two guys are really going to fall into what I'm discussing with the requirements definition and the system design. Then Carla is going to discuss system implementation, and Art's going to handle maintenance and support. Each one of these 4 building blocks is equally important. If you're missing specific steps within each of these areas, sooner or later the project's going to kind of go sideways. It's just a question of whether or not that happens at the beginning of the process, during implementation or a couple of years down the road. If you want the DAS to live a nice, long, healthy life, you're going to need to take care of monitoring and maintenance. If you want the DAS to be installed correctly, you're going to need to have certified installers that really know how to work with the product sets. You need to have good construction management. So going into the requirements definition phase, really it's just the acquisition of floor plans in AutoCAD, determining the services. This is the area where people kind of really get hung up. This is where we see a lot of RFPs fall apart, because defining the services can range your cost per square foot from 50 cents a square foot for a single layer public safety system to in excess of $2 a square foot if you have a multi-technology, multi-carrier design. One thing that I really don't like seeing in RFPs is when an RFP is led, we're going to require a public safety system first, but we want an add alternate for a cellular system that you can just add to that public safety backbone. You really can't do that. It doesn't work well. It's apples and oranges. There's antenna density related issues. There's a lot of equipment issues. There's a lot of incompatibility with filtration from lower UHF and VHF bands with the higher cellular bands. So you really need to know what you're doing up front in that services defined phase. The next step is the budgetary design process. In IB Wave, we put antenna layouts to floor plans. We put in the architecture. We decide what architecture is the best fit for that set of applications and the assumptions that we need to work off of. And then we get into the budget refinement phase. Now this step right here, this requirements definition, antenna systems will perform this to deliver a budgetary design package for free. We don't charge for these services. And we can get you about 90% of where you need to be in terms of price point and in terms of how the architecture is going to be laid out. The next step though is the actual system design, where we get on site, boots on the ground with an installation site survey, knowing the code, safety, and installation requirements, going through the ambient signal testing. This isn't something that was done 5, 6, 7, 8, 9 years ago at the beginning of the process. Now it is. So we benchmark all the carrier signals and all the carrier penetration and all the carrier technologies inside of a building, and it helps us validate our design process. And you have to go through that up front, and these are manpower intensive activities that also have a pretty high price tag in terms of the software and hardware to support that type of testing. Then we'll get into the design and predictions. We'll validate the design, we'll make adjustments to the design, and we'll deliver the final design and carrier coordination packages. Make no mistake about it, you shouldn't ever activate a DAS without carrier permission. You can't rebroadcast the carrier signals without getting the paperwork in order. So there's a lot of rogue systems out there fed by wideband bidirectional amplifiers. They're illegal. You're not allowed to configure them in that fashion. So antenna system spends an awful lot of time working with the right carrier contacts, making sure their requirements are met, and then putting together the packages to get the approval. So we facilitate that process between the enterprise and the carrier. Next, we're going to get into some of the product differentiators that factor into defining the requirements and defining an architecture or choosing an architecture that fits and satisfies the requirements.
Thank you, Jeff. So not to be outdone by my friend, I'll also stand up and feel a little bit like a motivational speaker. Who wants to change their life? So we have a great panel, a lot of industry specialists across a wide variety, but we cross-pollinate quite a bit, and we were talking about who should talk about what topic, and they said, Fred, we want you to do equipment selection. I work for Corning, right? So, okay, but I know what the answer is. But no, I'll try to be as neutral as possible. So, yeah, as Jeff has said, there's a couple things to think about. There's the architecture itself, and then once we get into a selected architecture, there is the manufacturers. A lot of the manufacturers, all make great products. There are different aspects to each of them, and we'll dig into that a bit. So from a high level, when we want to decide what kind of architecture we're going to deploy, those who have been in the industry know we started with a passive architecture, really just a repeater-fed system, which is all coax and antennas. Then we've moved into hybrid fiber coax architectures, which have sort of a little bit of both, but can grow and can accommodate neutral host systems. And now we're in the age where we have all fiber architectures available to us. When you are selecting some of the products or the specific OEMs that you want to decide, some of these key considerations are what you want to look into. Now sometimes that selection is already made for you. The carrier may already have decided based on preference. But usually, if they've decided on some of these points already. So some of the considerations: remote output power and power consumption. Those are two different things, but the amount of RF output from these remotes is going to be critical and should be matched to the venue. So if you have a large open air topology, you want to use a higher power remote so that the signal gets down to the users. Likewise, or the inverse, a small, dense environment may be more applicable to a lower power remote. Then when we get into ODAS, of course, we're talking about very high power. And then it comes to power consumption, because we have to supply electrical power to all these things, and you just may not have the infrastructure available to power very high power remotes, or you may come into the requirements where DC power is required. And in that case, we need to supply our own power directly to the remotes, and we can't count on building power. So those are the top two considerations. Then we get into physical equipment size. Everybody who has done deployments in major cities knows that space is at a premium. So we need to house the equipment both at the head end, and if we have equipment in the remote closets, we need to know how big the equipment is and if we have space to do it. So that's a key consideration. The last panel talked about converging Wi-Fi and DAS, and that was a great tee-up for me to talk about upgrade path. So upgrade path can be several things. It can be upgrade to support additional carriers, so you may have one lead tenant but have it neutral host ready, but it also may be an upgrade path towards other technologies, Wi-Fi, building automation, passive optical networks, and really the sky's the limit when it comes to services and technologies that we could foresee in the future that we'll deploy in a DAS system. A little bit more on neutral host, the way that we accommodate multiple carriers can be done in different ways. Depending on the OEM, you may have a situation where one remote has all the bands and each wireless service provider shares some of that amplifier for their own signal. Other architectures may use a dedicated amplifier for each wireless service provider. There are pros and cons to both. Cost and size come into play. But I heard the question or the issue raised, what if we don't know if a carrier is going to come on? We don't know, we can't foresee, if T-Mobile and Sprint are ever going to join the system. Well, in that instance, it may be in our interest to deploy the kind of architecture that has separate dedicated amplifiers for each wireless service provider, and then grow as other carriers agree to come on. And then finally, the services to be deployed. So we're at a stage now where OEMs have 4, 5, 6, 7, what's the highest? 8 bands, in one remote. So that covers a lot of what we have today, most of the bands, but we have WCS, we have AWS-3 coming. It's really probably never going to stop in terms of what new frequencies and technologies we're going to deploy. So what do you do about that to future-proof it as best you can? So in a typical installation, and for here I'm talking about both Wi-Fi and cellular DAS, what we have is dedicated head-end components, and then we have amplifiers at the remote, and we have dedicated coax, typically half-inch coax, through the building out to antennas. These other services, Wi-Fi, LAN, they all have their own parallel dedicated layer. And that works fine when you do them separately. But as the last panel said, we're getting to a phase where we want to converge all these networks onto one architecture. And it was sort of implied that that was something that's in the future, and it really is not. There is all fiber architectures available to you. The Corning One platform is that architecture. So it basically allows you to have the same amount of services that you want to deploy, passive optical networks, cell, Wi-Fi, and share a structured cable that you pull once. So we don't know what technologies are going to be on the ends, both as an input and the active electronics on the edge. But we do know that fiber has unlimited capacity and bandwidth, and it's frequency agnostic. So no matter what comes down the road, an all fiber optic infrastructure is where we think we want to go. There's several additional other benefits in terms of space, cost of installation, and all that. So real quick, just some of the benefits of fiber, all fiber in an infrastructure versus coax. unlimited bandwidth, as I said. Just the size, too. Sometimes, you don't have the ability to pull half-inch coax easily. Fiber is pretty rugged now, bend insensitive. There are benefits there. We talked about location-based services. On the last panel, they mentioned it. With a system like the One architecture, we have one-to-one optical connectivity out to the edge. The antenna is the remote, and so we can leverage these location-based services with almost a Wi-Fi-like granularity. Future ready, I talked about that. MIMO. So MIMO is a hit or miss in buildings. We typically don't see it too often unless the capacity requires it, but we may want to future-proof it. Right now we're at 2x2, but it can go up to 8x8, I think is the future. And so if we want to be future-proof, we want to add the redundancy for separate paths for MIMO. Gigabit Ethernet support, they talked about that in the last panel. So an architecture that can support the Wi-Fi, support the DAS, support PON all in one. Configurable sectorization, that's really going to be key to the carriers in the future. Those network radio assets are expensive, and you take a stadium at a college, which is empty 95% of the time. They spend a lot of money with the radios to cover the games, but it's unused most of the time. If we can steer capacity to where it's needed on the fly, that would be an architecture I think that would make the most sense for the carriers and for the venue owners. And with that, I'm going to hand it off to Ray.
I appreciate all of you letting us delay your lunch a little bit. I know everyone came here wanting to talk about power. It's the most exciting part of the DAS system. But it's actually critical. You can do the best design work possible. You can pick the best equipment possible. And if you don't have reliable power, it's not going to work. You're going to have remotes that go down. We've got a couple projects with Jeff's team that we're doing where we've gone in and they've figured out, hey, I've got 3 or 4 remote sections that are down. What's going on? It's power. They used a small power supply. It failed. And so they had widespread outages. They thought it was an equipment issue, and really it was just a basic electrician error. So there's 2 main areas we're going to talk about when we look at power. The head end, everybody thinks about the head end. Everyone thinks, hey, I'm going to back the head in. I'm going to put 4 hours of battery backup or 8 hours of battery backup in there, and I'm going to be good. The issue is they don't consider the remotes. Well, if you don't back up the remotes, it really doesn't matter if the head end runs 24/7. You're not going to feed any signal back. So when we look at the basics of DAS power, first thing we're going to think about, I'm going to put my remotes out there. Do I have available AC? Because I've either got an AC or a DC fed remote. Traditionally, the indoor remotes have been AC fed. We're seeing more and more DC. Well, I might be putting it in an IDF closet, telco closet. Well, that's great. Here in New York City, you may not have access to, you may be putting in a closet, they may not give you AC power. You may be responsible for getting it there. What's the cable distance from my, let me get all these up. There we go. So the 2 architectures you look at are local or remote. So localized, I'm going to put a UPS or a DC plant in every single remote. Remote, I'm going to put in one big power system in my head in, and I'm going to cable up. So there's advantages and disadvantages to both. The availability AC at each is one. The cable distance. How far my farthest remote is from my head in is going to dictate whether I can remotely power it or what method I can use to do that. I wish I could defy physics and the rules of electricity, but you can't. There's a thing called voltage drop, and you can't get past it. So space availability. This is probably the most expensive city in the country. Well, it might be really hard for me to find a 2 foot by 2 foot by 2 foot space in every closet to put in a power system and batteries. That may not be feasible. And it's not really very aesthetically pleasing, especially if you're going to be in a public venue. If you look in the New York City subway, you'll notice all the power is up on the ceiling because they don't want people to be able to touch it. Individual remote loads and voltage. This is, again, a city where we're seeing outdoor remotes used indoors. Well, that's a much higher power consumption, much higher power capacity, and that's going to affect your planning. Maintenance. If I've got 30 remotes and I put 30 UPSs out there, that means that every 2 to 3 years, I'm going to be out there changing batteries. It also means I now have 30 points of failure within my system. Is that a good design? Probably not. And then, can I go with a class 2 architecture? And we're going to spend a next slide on Class 2 architecture as to that's a remote power system method. And then length of backup time required. How long do I want it to run? Standard for some carriers is 4 hours. Standard for some carriers is 2 hours. And then some are just using evacuation plans. If the evacuation plan for that building is an hour and a half, that's how long the system has to be up. So Class 2 fundamentals. So the reason you're going to use a Class 2 architecture is it allows you to run the power cable just like a comm cable. It means that I'm going to be below 60 volts DC, and I'm going to be below 100 VA per circuit. There's a couple of misnomers on that. A lot of people think, hey, if I use a fuse panel, I can do that. I've got a 48 volt plant. I'm going to get 48 volts out, 54. And then I'm going to put a fuse panel on there with a 1 amp fuse. There's no possible way I'm going to pull more than 100 VA out. Well, the issue is that fuse goes bad, and the contractor goes and he goes, all right, I got a 25 amp fuse, and he sticks it in there. Well, now you're not Class 2 compliant. So in order to meet Class 2 compliance, you have to have 2 methods of circuit protection. So that if the primary method is bypassed, your circuit still cannot go over 100 VA. Class 2 circuits don't require conduit. They don't require an electrician to install. That can translate to about a 30% installation savings. Huge, huge materials cost. If you're your DAS integrator can now pull the cable themselves. They can pull a single Corning composite cable all the way from the head end to the remote, and that handles your communication and your power. There are a couple of caveats to that. In this city, if you are in a designated cable shaft, that NEC rule applies going between floors. If you go out of designated cable shaft, you will have to use conduit. City of Chicago is another caveat where conduit's used everywhere. We think that's political, but we won't get into that. So when you look at a Class 2 power layout, the head end, you're going to put all of your power there. We're going to put a big 48 volt plant in, depending on the size of your system. Off that, we're going to use a DC to DC converter. Our elimiter product has a built-in DC-DC. So it says 48 volts DC. We're actually going to raise the voltage up to 57 volts DC. The original systems that came out that were Class 2 compliant took 48 volts in and put 48 volts out. The issue with that is you actually can't calculate your voltage off 48 volts. You can only calculate it off 42, your battery cutoff voltage. So that means the max distance you're going to get with a 48 nominal current limited panel is about 1,000 feet. Well, if you got 40 stories, you're going to be in a lot of trouble because you're not going to go straight up and straight to the remote. It's usually up, over, around, through stuff. So 57 volts is going to give you about 2,500 feet. If you've just got a single small remote, you can home run it. Single cable, head in to remote, you're done. Power, communications. But let's say I've got one of the Corning HX remotes. Corning HX is about 450, 500 watts. Well, that means I can't use one cable. So what you have to use on the other end of that is what a product called the aggregator. So we're the only ones on the market that have one. It's UL listed. What that does is it aggregates the circuits to the end. You can take up to 8 pair and land them on there with a single bulk output. To meet NEC Class 2, you cannot bond pairs. We do bonded pairs for outdoor line power, and on that we can go 190 volts, 5 miles. Indoors, you can't do it. You have to aggregate the pairs at the other end. So why would I not go with non-Class 2? I just figured out it's a 30% cost savings. Sounds like it's great. Well, it might have an AC powered remote. I can still remotely feed an AC powered remote. I'm just going to put a big UPS in the basement, and I'm going to run the cable up. I'm going to use conduit. I'm going to size my wire gauge based on voltage drop. High power consumption remotes. About the maximum you're going to be able to do with a DC fed remote is about 650 watts. You've got to account for voltage drop again. We can't get past the laws of physics. Jurisdictional restrictions, again, Chicago. And then the same conceptual layout. As I said, we're going to put that AC UPS in the bottom and lay it out. Or if I've got a high-powered DC remote and I can't do it with the aggregator, I might just use a large DC plant, home run it, and put it in conduit again. And then head-in power. So touch on just for a second. Standard runtime is 4 to 8 hours. Huge range of power. For an enterprise, for a high-rise, it might be 1,000 VA. If we're doing a stadium, it could be thousands of amps. A lot of times we'll look at stadiums, they'll say, hey, I want this design to last. Well, that's where you got to look at modularity and scalability. If you're going to look at, hey, this system's going to last about 5 years, I've got to make sure that I've got enough growth capacity that if I put in a remote that's 3 times the size, I'm going to have the room to grow into it. And then space and environmental conditions. I wish they all went in nice, clean rooms, but they don't.
milestones, and really the whole process as to how DAS kind of starts from start to finish. And we really want to make sure that everybody understands this, because while everybody needs this and they need it to deploy quickly, it doesn't deploy as quickly as everybody wants it to. So setting the right expectations for your customers is absolutely critical. So we start with identifying a DAS need. And that can actually in of itself be a difficult piece. Whether or not a building understands throughout their entire high-rise in an environment like New York City, is it absolutely necessary? That's something that can require a design and some RF survey testing in of itself. In some cases, it's only the basement. In some cases, it's new construction with LEED requirements with low E-glass windows, which makes it a little bit more obvious. But when you have an existing building, first of all, you just have to identify, do I need a DAS? Do I need to enhance my coverage, be it cellular or public safety? And do I need to do it throughout the whole facility? The next piece, once the identification has been made, is the budgetary quote. How much does this cost? For some reason, a lot of people have a number of $10,000 to $20,000 in their heads. Where that number came from, I have no idea, but it's so common and we hear it all the time. And making sure that our customers know that it's actually going to cost anywhere from $100,000 to $1 million or more, depending on the size of your venue, is absolutely critical. Because right then and there, a customer can decide, how critical is this for me? Our services, whether it's public safety or more so cellular enhancements, they're becoming more and more necessary throughout our day-to-day lives, and it's becoming more of a utility. So now customers are more seriously looking at it if a carrier is not paying for it, and we've all seen a big impact to carrier funding in the last 6 months. It's more on the enterprise to look at it and say, okay, I need to take care of this for my customer myself. I need to ensure that this service and the satisfaction of my tenants and the people in my building are here. So making sure that they have a realistic budget is absolutely critical. The last thing you want to do is go through this entire process to end up with a customer having sticker shock after design and time and RF engineering has been spent, to have a customer say, oh, there's no way I can afford $250,000. I thought it was $10,000. So it's really important to get there to that stage in the game. This is an area where someone like Anixter can help to work up a ROM tool to give you and your customer a budget as to what's expected, what's realistic. Another area is our integrators. So you want to make sure you are working with the level of expertise that can do this and that can walk this whole process through with you. That's really what we're going to talk about right now in my portion of the presentation, is the importance of having the key players between the integrators as well as the contractors, consultants alike, and then the distributors who provide all of the parts and pieces to make this process seamless. So once the budgetary quote has been established and a customer says, yes, I recognize it's going to cost me $500,000 and I still need it. I've taken it to my upper management and we've decided to move forward. That's when an RF site survey can be done. Not the full-blown benchmark testing and the full-blown RF survey, but a site survey to go out and show to your customer, here is a layout, get some floor plans, have an integrator go out, take some initial test readings. Sometimes this step is missed, but oftentimes a customer, before they want to commit, especially when it's a big dollar amount, they just want to see a basic representation of what it's going to look like to the building. This is a step for the integrator, and this is an area where they're more than happy to take some floor plans, understanding where the market is and what type of venue and customer it is, and give that information back to you with a bill of materials and some floor plan layouts. Next, once that is determined, if the customer has said, okay, now I have a more realistic budgetary and I need to move forward, I need to get this put into our system, now starts the process of the initial design and bill of materials. At that stage in the game, if the customer is still moving forward, they recognize that it is going to cost them $500,000, $550,000, at that point an RF site survey is completed. That RF site survey, there is a cost associated to that. That is very time intensive. There's a lot of engineering that's done behind that. It's very fancy, very expensive equipment that a technician shows up to your building, walks your entire floor, every 50 square feet, takes all the measurements for each frequency for each carrier that's going to be deployed. And that information gets loaded into IB Wave. There is a cost associated to that. So don't be surprised when you get a quote and there is a cost from the integrator for that. Once that is completed, they're going to load that into IB Wave, which is the software tool that the carriers want to see the propagation maps in. And they're going to complete the detailed design and revise that bill of material. At this stage in the game, this is where the facilities team of the customer and a contractor, ensuring that you're working with a contractor that knows this customer and knows this building, is absolutely critical. They're going to know where you can run cable and where you can't run cable. And when you don't get that right, you cause redesigns at the very end, which can be very costly and time prohibitive to the customer. So it's really important to engage all the right resources throughout the entire process. After that has been completed, the updated design, the final design is completed, and then the statement of work is done. This is where the outline of all responsibilities through the entire process are identified for your customer, and they can really understand what stage each person plays and where they need to, where the responsibilities lie ultimately. This whole entire process from there, that can go anywhere from 1 month to several months, really depending on the urgency of the customer. At that point in time, once the customer is committed and moves forward, now is where the carrier approval portion comes in. This is the part where it can take longer. The fastest and easiest way to get that carrier approval, which you absolutely have to have before implementing the system, because you don't want to put in a $100,000 system, and that would be a low cost, that is a smaller system, and have a carrier say, you know what, it doesn't meet my standards, it's not up to my specs, I'm not putting it in, I'm not going to authorize it turning it on. That's the worst thing for your customer to hear. So the best thing to do is work with a tier 1 integrator who knows the carriers. Not only do they need to have the RF engineering portion, that's almost the easy portion, right? They can get that talent. However, the carrier piece, the relationships, knowing exactly what Verizon and AT&T want in this market, in these types of facilities, that's absolutely crucial. And only our tier 1 integrators have that type of knowledge. It's intangible. They can't buy it. You can't buy your way into the industry. You can't buy that type of relationship. So you need to work with these guys that have that, so that when that first go pass, when that first carrier approval package goes out, it gets approved as quickly as possible. Another critical component here is understanding what the carrier's requirements are, so that your customer and your integrator can work together to make sure the most cost-effective system that's up to the carrier's approval standards will be going in for them. So at this stage in the game, the majority, so it's a 12-stage process, which 75% of it is actually run by the integrator, which is why it's absolutely critical to work with a good integrator. As we move to the next process, we're going to see the contractor. So what I find really fascinating about this is that the contractor, they have one portion of that 12-stage process. They do help in regards to the site survey and making sure that that antenna is put in the right place, that I can actually run fiber where I want to run fiber, and I can run coax where I want to run coax. But the installation, that is absolutely critical. Even though it's not the majority of the entire time-intensive process, if you don't get the installation right, you will absolutely you can cause short to very big delays within your projects. You can put cabling in incorrectly. It won't pass the PIM test. There are a lot of downfalls to not having a contractor who understands DAS systems, the complexities of Heliax cable and the complexities of PIM, to put that in correctly. So you want to absolutely work with somebody there. Even though it's a small portion here, it can be a huge problem within the systems. I think most recently I had heard that anywhere from 60 to 70% of problems can happen in the installation throughout the DAS process. So once that is completed, you're going to move back on and bring the integrator in to do this commissioning, to do all their black magic and fancy tuning, as I call it. And then from the commissioning, they're going to do their acceptance testing. And at that point, they're going to redo that RF survey. So now they can complete their package to the carrier to turn on the system. So they've got the initial RF survey, which showed the carrier, this is what your signal looks like in my building without a DAS. They have their IB Wave design that shows, based on my design, here are the expectations. Here's how your signal is going to look afterwards. And once it's all done, they do another RF survey, which completes that package and shows the carrier that their design did what they said it was going to do. The carrier will review it, come out to the site, and they'll go ahead and turn it on. Now this process, from start to finish, can go anywhere from 3 months to 12 months, 2 years easily, depending on a lot of different variables. The customer's time, having the right parties, having the right integrators work on the designs, And then simply the carrier's response time within the market. So working with the right folks will make sure that that process can get expedited as soon as possible. So some additional portions of the implementation, we start with material procurement. This is an area where distribution really does play a large role in. So making sure that the equipment, the right equipment, is confirmed prior to arriving on site, making sure that you have the right amount of couplers, making sure that you have the right amount of jumpers. Jumpers have become a really big deal within our industry, particularly PIM-rated jumpers. You have to have the right stuff. You have to have the right connections and terminations. Otherwise, you can delay your project. And trying to find 100 jumpers in the last minute can be a very difficult thing to do. Meeting the current carrier's requirements, making sure that you're PIM-rated. Construction planning is absolutely critical, making sure that you're working with a contractor that can help you plan, understand the locations, understand where site access needs to be coordinated. Installation, we talked a little bit about the importance of working with the right contractor, making sure that they understand the difficulties with coax and PIM. And then commission and validating, making sure that the integrator is coming in, turning on the system, and making sure that it works correctly. So just some common installation problems are labeling, grounding. Here's a classic example of a kinked cable, which is something you don't want to see. This is really where the contractor can come in and make sure that it's done correctly. Heliax is a very difficult cable to work with. It is incredibly sensitive for as hard as it is, and people don't know that, people don't understand that. So working with the right contractor will make sure that you don't have to re-pull cable. Having the right splitters and couplers, and making sure that the directional couplers are installed the right way is critical. And then PIM, making sure that it's terminated correctly and it's not being hung in an area where it's got metal poles or things of other type of equipment of that nature that can cause PIM issues. So what we've done at Anixter is we've actually created what we're considering our elite DAS network. We're taking the best of the best, be it the best integrators who have carrier coordination skills, who have IB Wave, who have RF technical expertise, as well as the contractor space. We're ensuring that the contractors and the installers on these projects, we're making sure that they are certified on the cabling products, that they understand the PIM pieces, and also that they know how to install the systems at the head end as well as the IDF closets. Contractors really don't have growth initiatives to become a full-blown RF integrator. They're not going to do the design, but they want to make sure that when they're putting these systems in the building, that they're doing the best job they can possible. So what we've done is we've taken a network approach. We're just here to make sure that all the right players, all the right pieces, all the equipment, all the right OEMs show up at your customer's site so that you can have the best deployment possible.
Thank you, Carla.
Thanks.
Art, please go ahead.
There we go. The operations support. How many people? NOC, Network Operations Center. You've heard the term. How many people know exactly what a NOC is? All the screens, the telephone calls coming in, alarms popping up. Monitoring infrastructure can be anything from servers, switches, routers, DAS systems. That's what we're here to talk about today. I went to my first NOC in 1971 as an outside plant supervisor with Illinois Bell. I've been working in and around NOCs for over 40-some years now, 37 years of experience to forget because it's baggage, and about 7 years that actually applies. For INOC, we provide NOC services. We're an outsourced NOC. We provide it for all types of networks, wireless, fiber, microwave, and even the cloud services. So what I want to talk about today and what I want to cover is what goes into the planning for operations support and specifically for DAS. We're going to use our 15 years of experience building and supporting services for DAS networks. And from our point of view, so many times we're brought in late. There's no budget. The support costs isn't that much left. So now all of a sudden they're trying to get by as quickly and easily as possible, and in the long run it's a killer because we are responsible for maintaining and actually executing the service level agreements, the requirements of those, the business requirements. So when you're in there as a neutral host provider and selling the service to a carrier, they started talking about uptime. Yeah, we want 5 nines, forget that. 3 nines is probably more realistic. How much uptime are we going to have? How quickly do you respond to alarms? How quickly do you open tickets? How quickly do you resolve a problem? If dispatch is needed, how quickly do you need to be on site? That is what's built into a service level agreement typically. And the operations center is going to be the one that is challenged and tasked with maintaining those requirements. So the first thing that I'd recommend is bring in your NOC service, whether it's outsourced or internal. Bring those people in right up front when you're doing the proposals and make certain that it's covered at that time. And when you cover it, primarily it's the hardware that's going to determine most of the information that's made available to the NOC. There's going to be a host, it's connected to remotes. Maybe it's a gateway, they might call them nodes, whatever it is, you have that relationship on site. Underneath it, you have the power feeding it. Coming into it, you have the carrier connections, and I'm showing a black, a blue, and a red as being 3 different carriers on this one neutral host system. And up on top, you have a management network, a way to connect into that host or that gateway, connect into it and the other infrastructure using a separate path, a dedicated, it could be dial-up, it's probably a TDM circuit from the telco or whatever it is, it's a second path in, connects to some sort of management router, and now you connect into the gear. So the elements from a hardware perspective, you have a management connection coming in from the NOC, you have the carriers connecting into the host, that connects out to the nodes, and then everything is fed out to the handset or the whatever device they're carrying. When you're designing your network, put together at the very front end the ability to recognize when something fails and an alarm is thrown by the host. Is there any way to identify it with a specific node, the host itself, a technology within that host, because those are the things that will be unique to each one of the carriers. There are a lot of things that can break in a network that don't affect all 3 carriers, if it's a 3-carrier system. So you need to keep those things in mind, and you need to keep those separated. From a management perspective, a NOC perspective, we want hardware that is easy to manage. It's critical. So that gear should be creating industry standard alarms. So, we refer them to as SNMP traps. There's polling that goes on. There are a whole series of standards for the industry, and different hardware vendors execute those more effectively than others. Bring that into your initial consideration and make sure you have a solid set of alarms and messages coming out of that gear. And some sort of graphic user interface, the ability to go into the gear remotely and get a beautiful view of what's going on in the gear, and maybe even bring up troubleshooting guides and things like that. Some of the gear puts that in there wonderfully, and it makes it a pleasure to support from a NOC perspective. And then finally, the one that almost always gets overlooked, and that's why I put it on the bottom so you can overlook it, the management network. I mentioned the fact that you have a connection that comes in from the outside world into that infrastructure. It's a separate path, and it's that way because things can break from a carrier perspective coming into the gear, and if you're riding with that information, you lose your view into the gear. So you want an external path into the gear. So now if 2 or 3 of the carriers go down, fiber cut, whatever it is, you still have a path, an external path into the gear. Unfortunately, that path can also break. And if that breaks, you lose all visibility and you don't know, was it a fiber cut, a power outage, everything is down, or is it simply a management hiccup and your frame relay circuit is down from whichever carrier provided it. So you really need a second path in, and that's always overlooked. Should be a dial-up or something like that, really simple, but a way to isolate your problems. So once you've built that monitoring solution down there in that bottom left and you have the infrastructure generating alarms and information, now you need, from a NOC perspective, and this is where the rubber really meets the road. How do you get all of those alarms into a single pane of glass? How do you put together the workflow management tools and tie in the databases and the communication networks? You need to integrate your trouble ticketing system, your communication systems. You need a configuration management database where all of the information is stored. The ability for the first level NOC team to be able to visualize the services, the network, and what's happening within that so they can quickly diagnose issues. And that's what we do. We've integrated all of the tools into one solution from a single NOC position. You can see everything coming in. It all is tied to management databases. Tickets are generated, and it all comes into that first level NOC team right there in the middle. And they're going to take that information and start taking action on it. And they're going to have a run book that tells them everything that they need to do. This really needs to be planned out, thought out, and delivered. And that run book starts with, this alarm means this, it affects that carrier, here are the steps to remediate it. Needs to be in the book. For notification, if this occurs and you open a ticket, this carrier needs to be notified in this fashion. And all updates need to occur every 2 hours or 4 hours or whatever it is thereafter, and here's who has to be notified. If you need access into the site, good Lord, be sure to give us the information when you set it up and all of those requirements on what it takes to get into a site and when you can do work. If you think it's a big deal when you're building the network, think about it 3 o'clock in the morning on a weekend when something is down and you've got to get in there and restore it because it's a healthcare facility with 24-hour coverage versus trying to take care of Circuit of Americas during an F1 race when everything is locked down and now you have to be right on top of it. People are on site. All of that gets built into that first level, into the run book. You know exactly what has to happen because that Tier 1 team, and that's probably one of the most expensive elements of the support solution. It's not 3 people with pagers. They're trained technicians. They know how to communicate with carriers because they're going to have to open tickets with carriers. They're going to have to update carriers, provide information to them, and they have to be able to do it to each carrier individually because you can't be telling one carrier what's happening in another carrier's network. All that has to be built into it. And then the ability to escalate, do your on-site dispatch, call out fiber repair teams, whatever is required, down to the third-person support team. And then ultimately, all of those databases have to be drawn together because you're going to, from your trouble ticketing system, you're going to identify what incidents brought down service, affected the uptime, which carriers were affected, and you're going to need to provide SLA reports at the end of the reporting period because the carriers are going to use that for settlements so they can reduce the cost of the neutral host system they're buying from you. It's just the way it works. So you need a well thought out and solid program to do this. Okay. So in summary, bring us in whoever is providing the NOC service, bring them in up front. Make sure that the hardware supports the requirements for a neutral host, the reporting, everything that goes with it, all of your back-to-back agreements, they have to be tied in so that if you have a 4-hour response time or a 2-hour response time, time for alarms to come in, do the troubleshooting, determine somebody needs to be dispatched, get a hold of them, and give them drive time to get to the site with spares. All that has to be thought through. 24/7 NOC, it's not 3 people with pagers. You're at least 5 or 6 people deep. And they better be really good and know how to talk to the carriers. And then finally, a fully documented run book. And when you're planning this and putting the cost of it together, I would say that Tier 1 piece right in the middle with the 5 people and the run books and the tools integration and all that, it's something you can do internally, or it's one of the natural ones to outsource to someone else because they can help you manage the risk and the cost.
Okay, well, thank you, Art. Sure. Well, you ran a couple minutes over, so we can take 1 or 2 questions, but after that, please feel free to come up to us and we'll be happy to answer any questions. And the slides will also be available on the NADAS website. Does anyone have any questions? Looks like you're all ready for lunch. All right, thank you very much.